And finally, our last speaker for today is Professor Avinash Deshpande. And I want to say something personal and informal. I think I really miss Desh at RRI. I miss him for that last minute sprint to the canteen every day, which was always shocking every time it happened, like, what happened, Desh? But he would run at the last minute to catch lunch, and really miss that energy at RRI. Just a few words about Desh. He has contributed significantly towards studies of pulsar-magnetospheric emission regions and the elucidation of unphysically ultra-dense neutral hydrogen irregularities in the interstellar space, and several other things, of which he's very modest about his contributions. This is a part of the legacy in radio astronomy that he has given to RRI since 1980, and we're really glad that he has come here from Kanpur today, where he's now a visiting professor and has set up the new Astronomy and Astrophysics lab. He's also a visiting professor at IUCAA. He's primarily engaged in radio astronomy activities, signal and image processing, instrumentation, and understanding noise and uncertainties. As he modestly puts it, he's been trying to learn about these and other issues in the context of pulsars, interstellar medium, and radio interferometry. So again, a brief bio. Desh graduated in electrical engineering from the Indian Institute of Technology, Kanpur in 1980. So he's gone back there to IIT now to set up this ANA department. And he started his career by joining RRI in 1980. He did his doctoral research at RRI, which earned him his PhD from the Indian Institute of Technology, Mumbai in 1988, and subsequently did his postdoctoral work at the University of Tasmania from 1990 to 92. He was also at the Arecibo Observatory from 2002 to 5. He received the Shanti Swarup Bhatnagar Prize in 2002. So without further ado, Desh, and sorry for embarrassing you, but he's going to tell us about evolution of astronomy and astrophysics.
Thank you, Sumati. Thank you for describing somebody else than me. Yeah, thanks to Tarun for inviting me to say a few things about astronomy astrophysics theme at RRI. As you will notice, the astronomy astrophysics in the way that we have seen evolving in this institute really started in 1972, and so we are indeed celebrating the golden jubilee of course, my rendering is going to be of the evolution as it appeared from within, and of course it will have its own biases and shortcomings. I apologize in advance for any misses in the way I will go about describing, and I will certainly, of course, focus on the celebration of the peaks. This is, after all, a big celebration and time to rejoice the peaks. And of course, deferring the learnings from the so-called downs to a later analysis in due course and in cooler light. And I think it was being debated whether it was really called Cosmic Physics Group. It was indeed called Cosmic Physics Group. And the initial members were Radhakrishnan, S. Krishnan, Peter Shaver, even in those early days, Anand Kumar, Ravindra, Chandra Kumar, Arora, Ananta Ramaya, Ananta for short, Bhandari, Shukre, Ramraj, Manohar, and Balchandra. This was actually the time when IIA, called not IIA Bangalore, IIA Kodaikanal, moved to RRI. And right from the beginning, it was clear and asserted even officially that the activities will be in close collaboration with IIA and TIFR group in astronomy. So, in fact, the electronics and the optical grinding section were moved to RRI, and some of their members were in fact here, as I was told. I'm not sure, maybe Rajaram can confirm that. And the first set of students included Ramanuja, Siddesh, and Venkatakrishna. And of course, pretty much in the early days, we had Jayanti Mahalingam, who later better known as Jayanti Ramchandran, who was the computer expert. So I'll be talking of these different elements throughout my recollections, and thanks to Dominique for bringing to my attention the power of this word different. It says lots of things without really saying it, and you can read between the lines as we go along. The 29 sessions which were held in 72-73 must have been really special set of discussions, and it says that all aspects of radio astronomy were discussed, including basically it describes these as intense discussions, clarifications, and illustrative experiments. And this was taken up pending repairs of the Uti telescope, which the group was eager to begin to use. And all of you who know the way things have been done or had been done, one can imagine how enlightening experience this must have been. There was a rapid expansion in the next 5 years where NVG Sharma, G. Srinivasan, Rajaram, Haridas, Vishu, Prasanna, CHV Shastri, who was formerly a part of IIA, Nandakumar, Smiles, Dorai Swami, and T. Ramachandran appeared on the scene. This is also the time, and probably a little later, when the famous Astronomy Summer School was held. And as Rajaram described, there were several illustrious products of it which we hear of or heard of in the subsequent years. The early visitors included Peter Goldreich, John Abels, Christensen, Kaushik, Bill Coles, Ravi Prakash Rao, Osborne, Watkinson, and among those Ed van den Heuvel and John Abels and Kaushik and Prakash Rao were to visit more regularly than others. And these visits worth mentioning because they stimulated discussions that sort of formed basis for many further discussions and activities that were taken on by people in the group. In 77-78, there was a clear demarcation brought in. There were two groups now, theoretical physics and astrophysics, and radio astronomy, optical astronomy, and associated electronics. The precious influx then continued with Uday Shankar, Maya, Vivekanand, Kedarnath, Salomani, Ramesh Narayan, Dwarkanath, Sanjeev Durandar, Bala Iyer, Vivek Dhawan, Sam, and Sukhetu Bhavsar. There was also an interesting set of youngsters who grew at RRI, and which I think Rajaram mentioned those as the formula that Sharmaji adopted, which was basically catch them young soon after their BScs or diplomas and train them at RRI. And they included a set of people who have actually contributed at RRI, learned at RRI, and have gone out and done very interesting things. There were people also like R.K. Shivgaonkar and A. Krishnan from different institutes. Then Ravi Shankar and Pashupati and Jay Prakash, who joined later, who brought in a varied, uncommon flavor, which were to play important role in several aspects or projects at RRI. So of course, you are all aware of the stars at RRI. Ananta, who is sadly not with us today, M. Vivekanand, Dwarkanath, Arora, Ravindra, Uday Shankar. All these people did their PhDs based on the work that they did at RRI. Early JAP program, when it started in '82, RRI was lucky to get the real star Dipankar Bhattacharya, followed by Subhash Karbelkar, followed by Sridhar, and the list continues. Nimesh Patel, Sridharan, and B. Ramesh played a very important role in use of the 10.4 meter telescope at RRI, and they have gone on to do interesting things later on as well. Somnath, Nimisha Kantaria, Sushant Konar, Jahan Miri and Neeraj Mohan were the early set of students who are, you would have heard of them in terms of their work thereon. And of course, this stellar chain continued in the later years, now interestingly mentored by the early JAP stars. And so that list you can see here, many of these names may have been mentioned already. There were stars from RRI's own formal stream, which started in early 90s, which were also co-mentored by some others, and I have indicated as far as possible their mentors by some rudimentary tags here. Ramach, Jayadev, Saravanan really sort of set the stage and the tone of the quality of students that we could expect from this, followed by Indrani, Deepanjan and so on. And many of these names you will see doing interesting things in not just radio astronomy, astronomy in general. So of course, some of these people who did enter through JAP or otherwise, where RRI was successful in recapturing them. Among them, of course, you know, Dipankar was here, Ravi, Bhiman Nath, Sridhar, Shiv, and C.R. Subramanya, luckily, whom one could take from NCRA. Similarly, Anish Roshi, Sunita Nair after completion of postdoc, Bishwajit Flal for TIFR, Nayantara Gupta and Vikram Rana in more recent times. There were, of course, another set of motivated youngsters who have grown at the Radio Astronomy Lab at RRI, who took up new challenges whenever the opportunity arose. And the level to which they have grown is amazing, starting with things that they came with and learnt on the way. They are able to take major responsibilities in several projects. We, of course, had one more capture, Som Shekhar, who was from NCRA, and more recently, Kirti Priya. The engaging themes were, of course, many, as can be listed. This might almost appear like the entire astronomical pursuits, but you will find they are really the things that are been pursued over the last 50 years by some or other people or in collaboration within and outside the institute. Very loosely stated, the evolution can be described as starting from near and small to far and large, and that's really indicator of a growth in some sense. And so one of course began with the pet objects at RRI, and RAD's imprint was visible. Neutron stars and pulsars, the supernova and pulsar connection, how they are born, what their progenitors are, how these objects evolve, and how they emit was a major area of study. The second line that was close to RAD's heart was neutral hydrogen, its kinematics, phases, spatial distribution, and now we are beginning to use neutral hydrogen itself as a probe to study various things at various distances and various early epochs. So much so that almost everyone who came in contact with the early people got lured by some of these objects, and I don't think whether Rajaram remembers it himself. He had a nature letter to the editor objecting to somebody ruling out polar cap models completely, and he sort of argued in very simply understandable terms why such a conclusion is too hasty. Okay, so the interstellar and intergalactic ionized media, there are interests, more emerging interests in MHD and turbulence. Particularly Sridhar and his students have studied these in great details. Shiv has been looking at magnetic fields on various scales. Also Sridhar as to how to generate magnetic fields on small to large scales, and how the helicity can be brought in, and in a even though the turbulence and more random phenomena are at heart to begin with, how a larger scale order can be brought in. Molecular material and physical conditions and relative abundances was actually the focus of the millimeter wave telescope that was built here. Of course, additional interest in methanol measures and so on also continued, but the early work on carbon monoxide and silicon oxide measures was pursued with this telescope, and Nimesh Patel, T.K. Sridharan and B. Ramesh worked closely with Shukre in that time, and some of them worked with Srini later, and really extracted interesting information from these observations. Planetary, stellar and galactic dynamics, evolution, structure and winds have been areas among the areas pursued also by Sridhar and Bhimannath, and a series of investigations as to, in fact, one of Bhimannath's talk you would find would be titled as The Answer is in the Wind, and you will find that the losses and the feedback mechanisms associated with galaxy evolution are investigated. Accretion powered sources, high energy radiation and variability is something that both Dipankar worked on, and has been there is a large scale activity led by Vishwajit Paul. In this you will see a series of investigations that are using, in fact, the AstroSat data among other satellite probes. So, going back to neutron stars, pulsars, and supernova remnants, the people who really dived into it, among others, were Srini, of course, Deepankar, Dwarkanath, and M. Vivekanand, also along with Ramesh Narayan, and of course Rad. And these together, looking at various aspects of it, formed a kind of an attack which addressed several key problems and clarified several things early on, which set the stage for further development in these fields. Coming to extragalactic sources and galaxy clusters, tidal interactions and the spectral signatures, there have been a lot of work by Ravi Subramaniam, Lakshmi, galaxy cluster scale in terms of imaging and the evolution. Dwarka has been looking at it both in terms of data from elsewhere as well as our own GMRT, and spectral signatures in terms of Zunaev-Zeldovich effects and so on have also been studied by both Ravi and Dwarka and his students. The early universe structure formation and cosmology, of course, never separable from dark matter and dark energy, have been aspects of investigation in later years, more predominantly. And as you will see, some of the experiments and our involvement in some of the activities of more recent telescopes and their usage is tied up with that. So, of course, Shiv Seti studies various other aspects of structure formation and cosmology and dark matter and dark energy, but trying to look for signatures from very early universe in the sort of post-dark ages is something that you must have briefly heard in Sita's talk, and I will elaborate on it a little bit more. There is new interest, of course, in the variable sky. All the assumptions we used to make about the sky while using synthesis imaging, using interferometry, that the sky is stable, not varying, have all been realized to be not true, and we have gamma ray burst, fast radio burst now more recent, and of course variabilities in AGNs. So Deepankar and his students studied GRBs in great detail, including in its early phase of excitement when people did not know what these sources were really. Nayantara studies neutrinos and gamma rays and cosmic rays. Polarization has been a theme at RRI from very early days and will keep coming back to each time we make any measurement, even today, of the sky signal, because whatever polarization imprint that might be there or inadequacies in our measurement is going to haunt us. So its meaning and measurements and calibration will continue to be the theme even in future years. And of course you saw the X-ray polarimeter that is going to be launched will attack this problem at X-ray energies and provide first such measurements in an explicit manner. Synthesis imaging, interferometry, aperture synthesis, image reconstructions, of course, have been not just confined to the theoretical realm of its applicability. They have actually been used in reality, as one did at Gauri-Bidnur radio telescope, then later at Mauritius radio telescope, and we routinely use that with the existing other telescopes and with, of course, the GMRT. Coherence, noise, signal processing and instrumentation, discussions on it and bringing them to clarify our understanding itself in various aspects will continue, has been at the base of very early discussions and can never be removed from all the activities we do. The engaging creations, of course, where I'm going to describe more of actual, tangible, realizable facilities and instruments have been many. One of the first things that probably Rad engaged himself with people in NAL, more specifically S. Krishnan and Chandrakumar, I don't know whether he was part of NAL that time, and Salomani, was to build an astronomical clock. Uday Shankar, who came later, I think worked on the revised version of it, and Shashi has been an integral part of that activity right from those days, or at least later. While one was keen on using UT telescope, it needed the right kind of receiver, which were developed at RRI while they were waiting for the UT repairs, and a spectral line receiver was, I think, commissioned in early days at UT, with which Anantaramaya carried out his investigations in very early days. The Gauribidnur radio telescope, really an observatory, because many experiments could be conducted there other than just the T-shaped array, which was at decameter wave, was, I think there is a spelling B-I, not B-U. So this was, I think, initiated by C.H.V. Shastri, who is one of the unsung heroes in my view for the kind of initiative he has shown in radio astronomy field to bring up two facilities in a way where he doggedly went about trying to realize it and tried to get as much help as he could. And so it was a joint project of Raman Institute and Indian Institute of Astrophysics. Was a rare facility to create at those wavelengths. There were not many such. And of course, the antenna design was decided. The telescope was built. There was sort of equal involvement from RRI as well as IIA, so much so that the hiring was also done in that manner. The person who really turned a set of antennas and a network that was realized by then into a real usable instrument as a radio telescope is indeed R.K. Shevgaonkar. And he, along with Dwarkanath and Subramanyam, and with generous help from three people who were at Gauribidnur, Ashwatthappa, Rash Shekhar and Nanji Gowda, who along with support from Hamid and Ramanujam from RRI, really worked extremely hard to bring this telescope to a usable instrument. Shastri was always supportive and provided full freedom to make these things happen. The later Uday Shankar and Dwarkanath became parts of their respective thesis, took up the imaging of the radio sky at this frequency by using one-dimensional aperture synthesis, and they were successful in that. But there is a bit of history that cannot be forgotten, where D.K. Ravindra, who actually began to build one of the first, what would have been sort of the very early realization of a hardware Fourier transform machine. And this was a suggestion made by Bob Frater when he was visiting RRI. And the idea was very fascinating, that if you had a one-dimensional Fourier transform machine, you could take the visibilities, measure the visibilities along the one dimension by using different apertures placed along the north-south direction, and the east-west array can be used as one bucket, and the interferometric measurements could be Fourier transformed to get a one-dimensional strip of the sky in north-south. And of course the sky will appear to rotate past us as the earth rotates the other way, and you will find that you can complete the entire imaging in just one day. Of course, it became very clear that it's not going to be that easy, but there was no reason to stop one going ahead with actually producing this Fourier transformer, which successfully was produced. There was massive activity in the 10.4 meter building, the telescope that was to work at millimeter waves at RRI. There was also 1.2 meter prototype, which was described as one of the cutest telescopes by RAD during one of the IAUs, and that sat in the dome, under the dome, in the dome building, which probably doesn't exist anymore, nor does the 10.4 meter. And this is the telescope that was used by the students, early student, JAP students that I mentioned. One among those is still here. The other two are, as Rajaram described, were part of this exercise about the black hole shadow imaging. When the GMRT was not yet realized, there were intense discussions in this hall upstairs here with all the radio astronomers getting together and maybe few others to decide between dash versus dish. The dish finally won because the dashes had been tried out in what was the UT synthesis radio telescope, and the problems related to that were realized early on itself. And even if one were to think of that not producing as much as expected earlier, it certainly gave the foundation for making the right choice for the GMRT. So dishes were decided, light dishes, which also meant that they will have surface which is be more porous to photons at short wavelengths, and it meant that one basically was choosing the highest frequency at which it will work, which was not really going all the way up to 1.4 gigahertz, where the 21 centimeter famous hyperpoint transition exists in radio. So when queried about this, and encouraging comments were made about actually having L-band system incorporated in GMRT, as would be expected, Sarup turned back and said, would you build it? And of course, right at that place, decision was taken to go ahead with it, I think with probably small deliberations between NVG Sharma and Rad and others. So RRI took up the challenge of providing 21 centimeter system for it. The person who was to lead the pulsar activity at TIFR and as a part of the GMRD group was Krishna Mohan, and he had suddenly decided to go and take over or participate in his family business in pharmaceuticals, and so that led to a situation where Govind asked Brad, would RRI pitch in at this stage, and RRI did, and along with the 21 centimeter system, which was participated in and built by a group led by Sharmaji, in which Vivek Dhawan, even Ravi Subramaniam and Raghunathan and Anant played important role, along with very generous support from rest of the lab. The Pulsar challenge was taken up by again two youngsters whose names some of you might remember. One of them is certainly here, P.S. Ramkumar and T. Prabhu. They led the development of array combiner. Prabhu did that, and Pulsar backends to do Pulsar pre-search processing and later, another backend for doing the known pulsar studies themselves. And this really was a big contribution from RRI to this. There is one more contribution that somebody made from RRI, which, looking back, has brought in the kind of power that GMRD has. GMRD had earlier thought of putting a 3x3 matrix of dishes to do pulsar searches. This would have engaged almost, nearly at least 25% or 30% of the resource, which would not be really bringing in new information in the synthesis imaging with various baselines. So instead of 30, there would have been only 21 really independent separations. The others also will be independent, but they were not very different from each other. It was shown from RRI that this grating, so to say, is not going to give you as much sensitivity uniformly over the set of beams. The cracks in between the beams are going to have very poor sensitivity, and if you really take the average sensitivity, you can actually achieve that by incoherent addition of the various antennas, and you can match it to the peak sensitivity one was aiming for if one were to increase the bandwidth. And Swaroop instantly agreed to increase the bandwidth from 20 megahertz to 32 megahertz, and that made the difference. Mauritius telescope was another observatory that again CHV Shastri's brainchild and generously supported by RRI, so much so that almost everything else that happened there later was with RRI initiative and contributions. Uday Shankar went to Clark Lake and brought and assessed if the Clark Lake correlator, which was going to be decommissioned, could be used for Mauritius telescope, and indeed he said yes. And then that, as a part of the back end for this telescope, and the telescope built as a joint collaboration between IIA, RRI and the Mauritius University, was taken forward by him along with a bunch of students who have really gone ahead and done various things. I will not describe the rest of it that you have heard of, EOR experiments and AstroSat and so on. There are things to look forward to in the future as well, including things that are listed here. These are things that made all the stuff that I described possible. This is, of course, might sound very superfluous, but this is something that can actually make a huge impact on young minds when they see such things actually being realized in practice. So, inspiring, creative and charged atmosphere that is conducive for intellectual growth, uninhibited academic interaction focused to get the true understanding and not some superficial get going, open and freestyle discussions going on in various lounges and open spaces, and even heard from the rooms, which might lure even a bystander and get interested in that subject. Selfless, patient sharing of jargon-free knowledge and understanding that all the people who were part of these did to youngsters. And one could see that genuine urge to address and go to the depths of any technical issue. And we had inspiring peer group which were ready to listen and provide, they didn't care about what you thought, provided ruthlessly critical feedback. And one can go on, and you will find that all this might appear too ideal to be true. Believe me, this situation indeed existed at RRI, the witnesses of which are there still to endorse it. And given such a setting, no wonder people did what they did. We also saw beautiful examples of various people with complementary or matching strengths coming together and working together. Often one finds that many giants work in isolation and they have their own groups and followings, and there is hardly anything. While they might discuss occasionally, they may not work together intensely. We saw beautiful examples of that, and the RNs that kept coming together was not coincidence. They cohered and it became R square N square rather than 2 RNs. And you saw variety of examples of that. I am not going to go into details. What was important that I saw was the emphasis on visualizing physical picture and also seeing analogs was the key thread that drove many of these insights and developments. And I wish we can pass that on to the next generation. The person whom I and everybody misses at today's stage is K.R. Anantramaya. Had he been alive, the institute would have looked very different, particularly from 2005. Thank you for your patient listening.